Okay, so this is just a short video on how you calculate the direction for vectors, because it has to be written as a bearing, and this is an area people trip up on a lot. So what we're going to do at the end of the video is we're going to look at a question that was in the test. First two parts of that were all about the direction and the size of a vector. We'll go through that. But first off, we're just going to look at the basics of bearings and the key things we actually need to know before we can go ahead and start them. So, the very basics of it are your compass points, okay? And we have north, east, south, and west. Now, all your bearings, the standard for them is for them to be measured from north here. So the bearings are measured this direction around and always measured from north, okay? So that means straight up north is your starting point. And so we're going to call straight up north 0, 0, 0 degrees. And we use three figures for it because by the time we've got all the way around the circle, we'll have got to 360. So directly east, due east, that is 0, 9, 0 degrees, so 90 degrees. But we have to write it out in three numbers like that, so it matches. Directly south then is 180 degrees. Measured from here, you've come around 90, then you've come another 90 here to get to 180. So then, obviously that makes this one here 270 degrees. And by the time we got back around there, we complete the full 360 degrees. Okay, so let's draw a vector on here then. Let's say that our vector is in this direction here. Let's just call this vector A. Okay, so its direction is measured from north. So its direction is measured from here and is this little bit there. Okay, now if I told you that that bit there was 45 degrees, we would then know that the direction of A has come round and it's going to be 0, 4, 5 degrees, because here it started at 0, it's come 45 degrees and it's got to there. If we had a vector that was here, and again we knew that this angle was 45 degrees, its direction isn't just as easy as reading off because it's still measured from north. So what we want to be looking at is starting here at 0, how many degrees have we come to get to here? So if we come round, by the time we've got to east, we've gone 90 degrees. So we've already got 90 degrees. But then we've got another 45 to go. So the direction of vector B is actually 135 degrees. Okay, it's not 45. It's come round starting at 0 and come round. So you have to do it together. So if then I had a vector here, and again I knew this was 45 degrees, let's call this one vector C. We start from north again. We always measure from north. So by the time I come around here, I've got to 90 degrees. By the time I come around here, I've got to 180 degrees. By the time I get to C, I've got my 180 degrees plus my 45. So here, I'm actually at 225 degrees as being the direction of that vector. Okay, so the key thing to remember is, even if you know your little angle here, it's measured from north. And that's the really important bit that's needed when you're answering the questions. So let's look at that question then. So this is a question that was in your test. A car travels 300 metres north, then 400 metres west, and the car takes 2 minutes to travel that far. The question already did a little sketch of this out for you. 300 metres directly north, north is this way, 400 metres west, okay? And notice that the way they've joined these here is tip to tail. So the tip of this vector is touching the tail of that one. When you're doing scale drawings for your vectors, they always need to be joined tip to tail, okay? So it always has to match up like this, with the head of one arrow touching the back end of the other one. So let's start with question A. Calculate the magnitude of a displacement. So first things first, we want to work out what the displacement actually would be here. So the displacement is where you have travelled based on where you started, okay? So if our start point is here and we finished here, our displacement is just in this direction, okay? Our displacement doesn't really care so much about what we did on our journey, it only cares about where we finished compared to where we started, and it's the shortest distance between the start and the finish. The way we're going to work this out is using Pythagoras. So let's draw out that triangle. And we know this one is 300, and we know this one is 400, and we're trying to work out this side here. So for Pythagoras, what we have is that this side squared, we'll call it d for displacement, equals this side squared, so 400 squared plus 300 squared. Okay, so 400 squared is 160,000. Now remember, you can do this on your calculator. 300 squared is 90,000. If we add those together, we've got 250,000 is equal to the displacement squared. But remember, we have to work out what the displacement is. So that's going to be the square root of 250,000, which gives us a displacement of 500 metres. That's just answered part A. Let's calculate the magnitude of it. So at this point, with the magnitude, we don't care about its direction. We just care how far the car has travelled. So its finishing place is 500 metres away from where it started. But that information by itself isn't very useful. That's why we then need to work out the direction. Because if I told you, oh, the place you need to get to is 500 metres away from where you started, without a direction, you could be running 500 metres anywhere, and you're not going to get to where you need to be. That's why we need to work out the direction. So let's look at this. Part B, calculate the direction of a displacement. So we're going to use the same little setup we had before. We've got this far that we've travelled here, 300. We know then we went this way, 400. And we know that the displacement was this one here. And we know that is 500. Okay, now this is our north, and a bearing is measured directly from north. So the bearing for this direction comes round here, all the way round like that. And it's this amount here that is your direction, starting here at north and coming all the way around. Now, we need to come up with a way to work that out. So what we will do is, we'll look at this angle here. Let's call that x. We don't know what value this angle has. But we do know that if I start here and come all the way around, it would be 360 by the time I got back. So if I work out this angle here, I can take that away from 360 and it'll tell me what this direction is. So let's do that, and to do that we're going to need to do some trigonometry. So we can use sine, cos or tan here because we know all the sides. okay? I'm going to use tan, okay? So if this is our angle, if we write out SOHCAHTOA, so we remember what they are, tan is equal to tan of x is equal to the opposite over the adjacent. So if this is my angle, the side opposite it is 400. The side next to it, the adjacent, is 300. So if I want to work out what the actual angle is, I need to take the tan of both sides. So that means the angle is going to be tan to the negative 1 of the inverse tan of 400 divided by 300. And if we work that out on our calculator, we need to find the tan button here, and our inverse tan is the one above it, so we press shift and tan, and then 400 divided by 300, and that gives us an answer of 53.1 degrees. And we're going to stick to 3 significant figures because that's pretty much a standard in physics, so it is 53.1. Okay, that means our angle here, x, is 53.1 degrees. That is not our direction. 53.1 degrees is not a bearing, okay? The angle is measured from north. So our actual direction is going to be 360 degrees, because that would be the full circle. Take away this bit here, the 53. So we're going to have 360, take away 53.1, and that's going to give us 306.9 degrees. Let's call that 307 degrees. That is the direction of the displacement, because it's written as a bearing all the way around. Okay? You could do something else which is a little bit not standard. The standard for us in physics is always to write it as a 3-figure vector measured from north. However, if you didn't want to do this little calculation here, you could use your 53.1 and compare it to north. Okay, so another way of writing that, which wouldn't be standard but you would still get the marks for, would be if you wanted to do your 53.1 degrees, what you would say was it was 53.1 degrees west of north. Because if this is your north here, your direction is to the west of that, and the amount it's to the west is this 53.1. Though my recommendation would always be to stick with doing it this way and working out your direction as a 3-figure vector measured from north. Okay, so this should cover everything you need to do to work out a vector question. Okay, key bits to remember are you're always measuring it from north up here, and you need to know that you've got 90 degrees, 180 and 270, so that you can add bits on or take them away as you need to. Okay, and another little bit people always trip up on is remembering which identity to use. If you've got all 3 sides, you can use any of them, but just write yourselves down SOHCAHTOA so you don't forget which side you're using and you get that right. Okay, right, goodbye.